kernel index 0 is passed, but must be non-negative less than 0. What? Must be non-negative and less than 0. Oh. Must be non-negative less than 0. That doesn't make any sense. My understanding of this error is that basically it's using a compute shader to actually do the math for calculations, and it's failing. I'm not clicking on any links from you now. I don't trust you. It's going to be like a nunchuck video or something. Yeah, because basically compute shaders are just a way of pushing certain math to the graphics card as opposed to having it done on your CPU. All right. Fair. Yes. This was the video. And they're just, yeah, they're showing how it works. This is just a general lighting tutorial. This is from 2022. This doesn't help me. Try adaptive light probe. Adding that in. The project's open. No. Alright, so let's try it here. If it gives us the same error, I don't know what else to do. So, if I remember correctly, we had to go to the asset renderer. Asset. Change this to adaptive. Okay. Then we had to add a probe. So actually make this directional light mixed. Okay, and then we gotta add something. Let's go to package manager. Let's add pro builder, and we can throw in some objects. So it's not that it does any, it's still generating light probes. It's just generating them for you. And so you don't have to hand place them. And it does it before. It's not like it does it at runtime. It's like this is something you pre-process, So rather than me having to place the light probes by hand and do all that stuff, Unity built a system that will like figure it out for you, so you don't have to do it, and then you can make adjustments after the fact. There's a way to do overrides and stuff like that. Pro Builder is what I want. But the problem is the technique they're using to actually do the math calculations is failing on my computer. So when I go to bake the light probes, it says, oh, your computer's shit, so I'm gonna just not. And I'm like, why? And it's like, well, because, you know, I don't want to work right now. Which stinks, because it sounds really cool, and Unity advertises these awesome features, and I want to use them. Then I'm like, oh, Unity, why do you do this to me? Okay, so we're going to... There's create shape, create a plane. I'm gonna set this to 100 by 100. Put the pivot in the center. I don't know. And then we can reset. We go to editors, vertex color editor, and we apply this color. Okay. That's our ground. And then let's create a game object called level. Drop the plane in there. And let's also create a... I hate how they got rid of the... Let's create a 5 by 5 by 5 by 5. And vertex. Let's make that the vertex. Pro Builder. Object. Set pivot to selection. Okay, there we go. Set. So now we have this box. We're going to move that in here. And we can just duplicate it. To get some stuff for lighting. And then we can go to the lighting tab. Here. Actually, yeah, we'll leave it here. Lighting settings. Okay, change this to GPU. We generate the light. Oh, we need a we need a probe. Oh, is it working? Somehow it edited the Pro Builder. Did it actually create lighting? It looks like it did. So then I can say bake. Adaptive Pro's never been me. Generate lighting. Stop it. Lighting. Okay, so great question. Slow dive. Why do we need light probes? What do they do? Nather says, when you said something about GPU and CPU. Oh, yeah, okay. I'll explain that in a second. So Nather says, so instead of using real-time lights, the light kind of becomes a material. Yes, if that makes sense. It helps creating realistic lighting. Have you ever shut out light in a game only for the bulb to break? Yes. So light probes are used in conjunction with baked lighting. So what happens is you basically pre-process the lighting in your level and you bake them into the textures. So that, you know, if you're looking here, and you can see like it's dark on this side of the cube, it's light on this side of the cube, light on this side of the cube, light here, and dark here, right? So in a real-time lighting situation, if I move this light, right? Actually, not moving it, but like if I move this light, the lighting changes, right? So now it's darker on top because the light's facing a different source, right? Now this is what real-time lighting lets you do. Real-time lighting will let you do dynamic lighting like this, right? But let's say in your game or in a less intensive game on your phone or on web, your light doesn't move, right? What you can do is you can bake the lighting. So now I'm going to say, okay, this light doesn't move. In order for, and I think this is why it's not working, all these objects, I'm going to mark all these objects as static, which means I'm telling the game these do not move. And then I'm also going to mark the light as static, telling the engine that this light doesn't move, right? It can use that information to basically say, okay, if the light is always going to be in this position and these cubes are always going to be in this position, I'm going to pre-calculate what the textures on those on the surface of the plane is going to be, and on the cubes I'm going to pre-calculate it all. I'm going to bake it right into textures because I have to load the textures anyway in order to display them in the game. So I'm just going to bake that in. That saves a huge amount of processing time because, like Nather said, real-time lighting is expensive. You have to calculate how that texture looks relative to the light every frame, right? So with that in mind, not every object in your game is static, right? The player's running around. You might have NPCs. You might be, doors open and close. Those things aren't static. They move, right? They're dynamic objects. So you could use mix lighting in this case, where it will use real-time calculations based on the lighting for just the moving, or you can use pure baked, which means that this light is baked. Now, what's nice about light probes is think of them as points in space that hold a light value. So you can put these little tiny dots all around your map and say the lighting information, the amount of light in this area is this. It's this bright, this color. That's correct. Baked lighting will also create shadows that do not move. They don't. In fact, Nather's example is very point. If like there's a light bulb and I shoot it and it goes out, it's still casting shadows because that the light from that is baked, right? Now you can kind of like potentially override that with real time, but it gets tricky. What light probes allow you to do is now, let's say I have a enemy, I have a goblin, and he's coming out of a dark room into a light room, but all the lighting is baked. What I can do is put these little light probes around, which have pre-calculated what the lighting is in all those little spots that I place them. And as my NPC comes by light probes, it calculates what light probes are closest to it, and it uses the lighting information that's stored in the light probe to light itself. So it's like an alternative way or a cheap way for it to light itself, as opposed to having to calculate what light should be on its surfaces based on what lights are in the room. If that makes sense. So it basically says, okay, what is the closest set of light probes to me per, I don't know if it does it per pixel, per surface. I don't know the exact stuff for it, but it basically says, okay, I have a light probe over here, I have a light probe over here, these are the values, I'm going to use those values to light parts of myself. And then what it does is it makes those NPCs that like walk through the rooms get put into shadow or get put into light, or if they walk by a torch, they get the orange glow to them, because those light probes store that information, and it can say, oh, I'm close to this thing, I need to use this lighting information, or I'm close to that thing, I need to use this lighting information. So that's what light probes do. So this is working. So it's working in the test project. So there's something funky about my current project that's causing issues, which I hate, because that means it could be anything. Probes. So if I turn on, yeah, see, look, it generated the cells, it generated the bricks. I can turn live updates on. Display probe. See? So all these little dots contain lighting information, and it spaced them out. And you can see that like in certain areas, it like made them possibly more dense, or well, at least it's supposed to. I guess you can probably make adjustments and say, okay, I'm going to override the probe spacing here, and I want them to be no more than 9 meters and no closer than 3 meters, and then it's going to readjust, right? Or I might want it to only be 1 to 3 meters away, and then there's going to be more of them, right? So see, it's like placing probes on these, and it's calculating certain lights. This is what it should do in my level, but for some reason, it's not doing that. So, okay, so we know it works. Tricks to save frames. Exactly. It's all just tricks to save frames. So, all right. So we're gonna not save this. All right. So there's something weird about my project here. Let me put it back to shadow. I don't think this matters. Let me put it back to, like, I forget. What is the difference? Specifies the lighting mode of all mixed light. I forget which one is like the one we want. Unity lighting mode. Okay, so what do we do here? Baked Indirect combines real-time direct lighting with baked indirect lighting. This mode provides real-time shadows with real-time shadow maps. This lighting mode offers realistic lighting and reasonable light shadow fidelity and is suitable for mid-range hardware. Shadow Mask combines real-time direct lighting with baked indirect lighting, supports baked shadows for distant game objects, and blends them automatically with real-time shadows. Shadow Mask lighting mode is the most realistic and most resource-intensive lighting mode. You can use quality settings to configure the performance. Subtractive provides baked lighting and indirect lighting. Renders direct real-time shadows for one directional light only. This lighting mode does not provide particularly realistic lighting, but is suitable for low-end hardware. Okay. So let's do Shadow Mask. And then let's clear the lighting data, clear out the baked data that we have. Let's delete this adaptive probe. Let's want to duplicate it. Let's delete this. Save. Save the project. Let's go back. Rendering. We've turned all this off. Okay, we have this. This is our settings that we didn't touch. Okay, let's close that. Let's go back to our URP settings. The renderer, no, not the renderer, the asset. We're going to say light probe groups. We're going to switch it back to light probe groups. I'm going to switch this back to light probe groups. Okay. Save. Now we're going to bake, generate lighting. So we're going to let this build. We don't have any errors. So the default render pipeline that it's using for the editor is the PC one. If we go here, it's building the light maps. I turn lumen and mega lights on full blast. YOLO it. I like it. so we're using the PC one. Can I just get rid of this mobile one and just use the PC one? I have a feeling it's probably not a good idea. If I go to graphics, URP, I forget where you... Like, where do you set the one that's on the quality, I think? Yeah, mobile. Like, let's just trash this. Allow clients. Yeah, let's just trash this. We're just gonna say everything's using the PC. Okay, so let's get rid of mobile. So we have one renderer, one asset, I go back to office hours for a sec. Lighting per pixel, probe groups. Still, yeah. So another thing, slow dive, is that you need to bake the lighting first and then bake your probes, because the probes use the baked lighting data in order to do their calculation. So they like they look around and say, based on where I am, what is the baked lighting data around me, and give kind of like an average, and then that's what it uses. So you need to bake the lighting data first. And of course, disclaimer. Hashtag disclaimer. My wife just texted me. She's watching I think it's on Netflix. No, I think it's on Paramount Plus. I forget. It's a new show called The Agency, and she's like trying to go to bed, but every episode that she watches ends in like a cliffhanger. So she's like, God damn it, I gotta watch the next episode. So those mirror spheres are for reflections. Well, on movie sets, I'm not exactly sure what they're for. But in game engines, when you see those are for like reflections. Those are called reflection probes. They basically work the same way. They're pre-calculated data that the game engine can use for like a reflection in metallic or reflective surfaces. It's like a texture, a pre-baked texture that I can say, oh, I should be reflecting this skyscraper or this lamppost or whatever that I should be able to see based on my angle. I don't have anything reflective in this scene, so I'm not do it. But you could, if you did have like Like for example, I could try to make those blood pools like slick and make them look liquidy and use a reflection probe to try to make them reflect. I don't know if it would work in WebGL, but we could try. Supposed to be working on screens. This was supposed to take 2 seconds. Unity sold me a bag of goods. They're like, oh, adaptive probes, super easy. Drop them in. Boom, done. And on an empty project, it worked perfectly. Okay. All right. So we baked the lighting. So now we're going to change this back to adaptive probes. We're going to keep it on medium. We're going to leave GPO streaming off because we didn't have it on in the other one, because maybe that was causing the problem. GPU streaming. Okay, so now we're going to add a lighting adaptive probe volume. Drag that up here. Oh, come on. Okay. We're going to use global. Actually, we can use this. We can reset this to the middle.